Hey guys, how are you doing? So we'll be doing this question of probability. This is the probability playlist. We will be solving good, like challenging questions of probability. New questions, I guess they are. I guess you like the questions. So a fair coin is tossed repeatedly. What is the expected number of tosses before HT shows up before the for the first time? Right. So basically this question can be solved using Markov chains. Let's see what exactly Markov chain is. In Markov chain, basically there are some states. So let's denote the starting state to be S, in which we have tossed no coin at all. We have to find out for HT. So basically we will be doing like this. Let's say we get a head. What is the probability of getting a head from the start state? Half, right? What is the probability of getting a tail? Half. But tail again sends us to the starting state only. Do you know why? Because our this HT starts with a H. So if we don't get the first H, if we get at first T or something or other T, then basically we are reaching to the again to the starting state, if you think in a way, right? Isn't it? So that is what is happening over here. And there is again another half probability of reaching to HT. There is half probability of reaching to the same state, because if another H comes, like there is two possibility, either HH or HT will come, right? Okay, either HH or HT will come. If HH comes, basically we are starting from the H position again. If HT comes, then we have reached our final destination, right? Yeah, that's fine. From yeah, this is it. So basically, let's say, let's denote uh, expected number of moves to reach from state S to HT is equal to, let's say, X. State H, S is basically the starting state, state H is this state, to HT is, let's say, Y, and state HT to state HT is Z. Now we'll do a basic observation which will tell us Z equal to 0, as you are reaching from yourself, you are reaching to yourself. So basically the expected number of moves to reach from you to you is obviously 0, right? Now let's create some equations except for Z equal to 0. If we are at the starting state, the number of expected movements will be Y, like number of expected steps will be Y, sorry, X, my bad, X, which will be equal to, now we toss the die, like, sorry, toss the coin, right? Now we have probability of either half of reaching to its own state, like either we reach to itself or either we go to H, right? There's a half probability of reaching to itself and half probability of reaching to Y, and this plus 1 is added because we have moved one, we have tossed one coin, right? So we have moved one step, we have done so we have done a toss, and hence, so x by 2 equal to 1 plus y by 2. This is equation number 1. Let's write the equation 2. Equation 2 will be from the state of H, it will be the expected number of steps from H to HT will be equal to 1 plus half of y plus half of z, isn't it? And we know that z equal to 0, this is 0, and hence y equal to 2, which will obviously give us from equation 1 x by 2 equal to 1 plus 2 by 2, 2 cuts equal to 2, which means x is equal to 4. So the expected number of tosses we need to reach xx ht is 4 from starting position, from starting state s. So this is the expected value, right. uh, what is the expected number of tosses before tt shows up for the first time? This you can try out yourself, pretty similar. I'll draw the Markov chain. Let's discuss the Markov chain, because this is everything we need in this question, and then it's just forming equations and solving it, right? So let's say we are at the starting point. There are two possibilities: either t falls, so we need t, either h falls. H falls means we are again back to the starting state. Here if h falls, then we are again back to the starting state after t, and if t falls, then we are here, right? So this will be the Markov chain for this question. And what is the probability that ht shows up before tt? So I'll ask you to try this question out on your own once. What is the probability that ht shows up before tt? It will be kind of the chances of ht, like you have to find out the number of times ht can show up before tt, kind of something like that. So yeah, it won't be easy. Like first solve these two, and then you'll get a basic idea as to how to solve it. We are this is a cut the knot. I have taken this source, the source is cut the knot, and I am solving the question from that. The question is called anyways, whatever the question be called, this is the solution of the question. I hope I hope you have understood how we approach this question. This question could have been like h t t h or something like this. So every this type of question should be solved with Markov chain. Okay, I hope I am pretty clear with the solution. If you are not clear, and if you are stuck in this question, please write in the comment section, and I will create another video explaining how exactly this should be done. And if you are stuck with this too, you can tell me, but I don't think this is pretty similar to this one, so I don't think you should be stuck when I have already created the Markov chain, right? So I guess that's it. I hope you like the video. If you like it, please subscribe, and we'll get on with more interesting questions of probability. Okay, bye.